Okay, for this video, I'll be going through thermal properties of metal tutorial, question number 5. Okay, determine the mass of ice. The mass of ice at 0 degrees. That means I have ice, and it is at 0 degrees Celsius. Okay, required to add to 0.3 kg of water at 50 degrees Celsius, so that the final temperature of the water is 0 degrees. Okay, so we will need to draw our heating and cooling curve again. So for the water, it is actually cooling. So this is our temperature versus time graph. So initially the water is at 50 degrees. Okay, then after that ice is added, so the temperature will decrease and it will reach 0 degrees Celsius. Okay, now for the ice, it is actually a heating curve. Temperature 0, temperature degrees Celsius, this is the time. So the ice is initially at 0 degrees Celsius and it will continue to be at 0 degrees Celsius, because once I add the ice in, it will start to melt, and all the ice must finish melting before the temperature increase. But I need the final mixture to be still at 0 degrees. So over here it is just my LF, latent heat, specific latent heat of fusion, whereby there is a change in state from solid to liquid. Okay, and there should be no more increase in temperature after that. So after unpacking all this information, then we can solve using the equation. So for the ice, it is actually Q equals to MLF. Okay, and I don't know what is the mass of the ice, but I know LF. It is at the front of the tutorial. For the water, the energy that it is transferring out will be MC, change in theta. Why do we use specific latent heat? Specific heat capacity, because there is only change in temperature. So the mass of water is 0.3. This is 4200, and the change in temperature is 50 minus 0, so it is 50. So this amount of thermal energy that is given out by the water will be transferred to the ice, and we assume that there is no heat transfer or thermal energy or energy transferred to the surrounding. So we can actually equate these two together. So M multiplied by the specific latent heat of fusion will be equal to 0.3. Okay, so you will see that actually the heating and cooling curve is very important, because once you have all this information down, that means you also need to be able to unpack this information. You need to know whether is there any change in temperature, whether is there any change in state. Okay, so this is very important. So if you do your calculation, then M will be equals to 0.3 4200 50 over 0.33 times 10 to the power of 6, and your final answer will be 0.191 kg. Okay.